Okay, the last thing in lesson set 35 is over canceling, and I did not mean to have the purple written down, but I had started this recording and the phone rang 30 seconds into it, so I already have some material written down for you. What I was talking about is if you have 4 times x over 4, if x happened to be a value of 5, then you would have 4 times 5, which is 20 over 4, and 20 over 4 reduces down to 5. So if I wanted to, I could cancel the 4's in the very beginning fraction and just be left with x, which I said was 5, and that works. However, if I look at the next fraction that I have, and it says x plus 4 over 4, if x is 5, I get 5 plus 4 over 4, and that gives me a value of 9/4. If I were to take the fraction and say it was 5 plus 4 over 4, I cannot cancel the 4 as an addend, and it's not a factor, it's a separate term. I cannot cancel that because if you cancel that, you are left with 5, and that is not the same as 9/4. So this is an incorrect procedure to use, and you can't do it. You cannot do this process. You cannot cancel terms in a fraction. It has to be a factor in order to reduce. So if I look at the next example, the 4 in the numerator, since the 4 is a factor in the numerator, the 4 can cancel, and you are left with x plus 1. And that is correct. I mean, that's a correct process as long as it is a factor. And you could go through, I don't know, let x be a number. I don't care what number you let it be. If you say that x is 6, then you get 6 plus 1 over 4. If you wanted to continue with that, you would say it's 4 times 7 divided by 4. You could say that's 28 divided by 4, which is 7. Well, the 7 is that value of 6 plus 1 that we talked about. So the 4 can reduce in this format that gives you 7. If I reduce the 4 here, you are left with 7. So as long as it is a factor, you can reduce it. So I look at example 6. Is 4 a factor of both the numerator and the denominator? Factor means multiplying. 4 times the quantity a minus 3. 4 is a factor, so that can reduce, and you are left with a minus 3 when you simplify that. So that is a process of simplification that works. Now if I look at the next example, I have 3 times the quantity x minus 2 divided by x minus 2. This is a quantity in the denominator. That same quantity is a factor in the numerator. You have 2 factors in that numerator. One of them is 3, and you are multiplying 3 times the x minus 2. So since the x minus 2 is a factor, that does reduce, and you are just left with 3 for an answer after you simplify that particular expression. So we could continue on. What if I look at example number 8? What if I said I had 3p plus 3 divided by 3? 3 is a factor in the first term, but I can't just cancel that 3. 3 is a factor of the second term, but I cannot cancel just in a particular term. So what I have to do is I look at that numerator and I say, okay, what can I factor out of both of these terms? Because if I go to the previous example, I could have written the numerator as 3x minus 6. If I go to the example before that, I could have wrote the numerator as 4a minus 12 divided by 4. And I cannot just take the 4 out and be left with a minus 12. I cannot just reduce here and be left with 4a minus 3, because that's not what my answer is. If you were to write that as separate fractions, 4a over 4 minus 12 over 4, you would notice that the 4's cancel and you are left with a for the first term, and your second term, that's a minus sign there, and your second term, 12 divided by 4, is 3, and you are left with a minus 3. That's not what you get if you cancel those 4's. That is not what you get if you cancel those two terms right there. That's not what you get. So you have to make sure it's a factor in both. So if I look at this, I can factor out a 3 from both terms in the numerator. That leaves you with p plus 1. Now don't forget that plus 1. I stressed that in the previous video. Some of you are going to forget that plus 1. And we divide that by 3. So now the 3 is a factor in the numerator, and I can of everything in the numerator, and I can cancel that with that denominator value, and you are left with p plus 1. Now, yes, you can get that if you write that as two separate fractions. You have 3p over 3 plus 3 over 3. 3 over 3 cancels, and you are left with 1, plus 3 over 3 is, you are left with 1p, and 3 over 3 is 1, so you get that solution of p plus 1. I'm really going to try to force this factoring part, though. Some of you are going to think, I can do that in my head right now. I could take a 3 out of everything, and if I take a 3 out of everything, I'm going to be left with p plus 1. That's great, but I have seen how some students do that, and you're going to make some mistakes. So until you get used to it, I would strongly recommend that you factor it out. Now, when we get into next year or the year after that, yeah, we can do some of this stuff mentally without error. So if I look at the numerator right now, for example, number 9, there is a factor of 3 and x in both terms. So the greatest common factor is 3x. What are you left with? I factored out 3 and x from the first term, and remember, if you factor it all out, you are left with 1. If I factor out 3 from 9, I have a factor of 3 left. I took out an x, it was x squared, so I have an x left, and I am dividing that by 3x. Since 3x is a factor of everything in the numerator, the entire numerator, I can cancel the 3x with the 3x in the denominator, and you are left with 1 minus 3x. And there's your solution. Now, like I said before, you could say it's 3x over 3x. That's 1. And if I were to reduce 9x squared over 3x, then I get 3x. Okay, sorry if I seemed distracted on that last one. My cell phone was vibrating, and I figured I saw it was from the school, so I thought a one call now would be coming across the house phone, and my phone would ring in the video. All right, so we have one last example here. If I look at the numerator, what can you factor out of the numerator? Well, the greatest common factor is 5x. That leaves you with 1 minus 5x in the numerator, because the distributive property would give you 5x minus 25x squared. Now I am dividing that by 5xy. Now the difference with this one and problems we've had in the past is that everything in the numerator does not cancel with the denominator. So I have factors of 5xy in the denominator, and a factor of 5, a factor of x, and a factor of the quantity 1 minus 5x. So the 5 cancels, the x can reduce or cancel, and what you are left with in this example is 1 minus 5x over y. And that is your simplified form of the fraction. So this lesson gives you a little bit more on practice on factoring, and then it shows you how you can actually factor those greatest common factors. So lesson set 35 is due on Sunday at 11:59. You can watch these 2 recordings, and if you have any questions, I have a Zoom meeting set up for you on Thursday at 3:30. as I think some of you might have some questions that you want to answer. So I went ahead and set up a Zoom meeting for you Thursday at 3:30. So we will see you then if you have questions.